Hello everybody, welcome to Medical Statistics class. My name is Isaac Ajao. I will take you a topic on basic theory of epidemiology. Following this up now, I'll be able to cover these topics. If I'm not able to cover all, it will be in another series. Definition of epidemiology, aims of epidemiology, statistics, and clinical medicine compared. Measurements in epidemiology. Then what are p-values? Sensitivity, specificity, and predictive values. So what is epidemiology? This is the study of distribution and determinant of health-related states or events in specified populations, and the application of this study to the control of health problem. Of course, we have been hearing of epidemiology. And then what are the health-related states or events in a particular population? The aims of epidemiology: to describe the distribution, magnitude of health and disease problems in human population. Then want to identify risk factors known as etiological factors in the pathogenesis of a disease, and to provide the data essential to the planning. That's why statistics come in. The data essential needs to be provided for prevention, control, and treatment of disease. Epidemiology and clinical medicine, there are basic difference between epidemiology and clinical medicine. And the difference is that in epidemiology, the unit of study is a defined population or population at risk. In clinical medicine, the unit of study is a case or cases. In clinical medicine, the physician is concerned with disease in individual patients, whereas epidemiologist is concerned with disease patterns, the pattern of the disease, how it occurs, the frequency of occurrence. That's what the epidemiologist is out for. Epidemiology is those concerned with both the sick and the healthy. Then we want to compare clinicians, statisticians, and epidemiologists. What are their roles? Clinicians are interested in cases with the disease. The statisticians with the population from which the cases are derived. And the epidemiologists are interested in the relationship between cases and the population in the form of a rate. So what an epidemiologist expects is nothing but the rate, and the rate is supplied by a statistician. In clinical medicine, the patient comes to the doctor. Of course, when you are sick, you go to the doctor in the clinic. In epidemiology, the investigator goes out to the community to find persons who have the disease or experience of suspected causal factor in question. So we have measurements in epidemiology. We have that of mortality, morbidity, that has to do with the sicknesses. We have the diseases on ground. We have measurement of disability, how many physically challenged people we have or disabled. The measurement of natality, morbidity of antenatal care is otherwise known as birth rate. Measurement of the presence, absence, or distribution of characteristics or attribute of disease, and so many of them like that. Then we have p-values. What are p-values? P-values, you might be hearing about it. P-value gives the probability of any observed difference having happened by chance. Difference may not be difference in relationship. So the probability that the difference observed or the relationship observed is it just happened by chance. That is as a form of sampling error. It's known as probability value, and we have different value for that. We have to, if it's 0.5, it means that the probability of difference having happened by chance is 0.5 in 1. So, and we have some other ones. We have 0.05. Then what are statistical significance? The term statistical significance means unlikely to have happened by chance. If you are carrying out a test and you are testing for relationship or difference. So you want the p-value to be very low so as to increase the significance of the finding. That's what we're talking about. So if p-value is 0.01, is considered to be very highly significant because it's very, very low. So that relationship or difference has to be significantly related or be observed. If the value is too high, it means the statistical significance will be very low, which the researcher doesn't want. So we have the interpretation: 0.05 is significant, 0.01 highly significant, 0.001 significant. Then we have sensitivity, specificity, and predictive values. We use this to analyze the value of screening or test. For each patient, disease itself may be present or absent. The test result may be positive or negative, either of the two. So this is a contingency table summarizing specificity, sensitivity, and predictive values. So this table describes what you are about doing, or what you are going to do. How would you obtain the sensitivity, sensitivity, and the predictive values. The column here, under this column, total here will give us total for the true positive and plus that of false negative. Then when the disease is absent, the false positive plus true negative added together will give us the column total. Then the row total will give us this, what will give us row total. Then the row total for negative is this. This is from test, for the screening test. Of course, I think you remember our type 1 error. Type 1 error is the error committed when a true hypothesis is rejected. And the other one here is when you are accepting an hypothesis that is not true. So then we go to definition of all this. True positive: when sick people correctly diagnosed as sick. Somebody is sick, as correctly classified or identified as sick. That's what we want, and it's referred to as false positive. True positive. Same thing with false positive: elderly people incorrectly identified as sick. Somebody that is elderly but classified or identified as a sick person. That is false positive. So on, and we have in general positive is referred to as identified, negative is rejected. So we can use these terms: true positive, correctly identified; false positive, incorrectly identified; true negative, correctly identified; false negative is incorrectly rejected. Sensitivity. So sensitivity, another name for sensitivity is true positive rate, or TPR. It relates to test ability. That's the ability of a test to identify correctly the condition. For example, medical tests used to identify a disease. So sensitivity of the test is the proportion of the people known to have the disease. So if the person is having the disease and you carry out the test, there are so many tests you carry out. If you use X-ray, it will reveal what is inside of the chest or any part of the body. So if it is being used and the test is okay, the apparatus, the device is okay, it will reveal the true status. So the higher that, the higher the sensitivity of that particular tool we are using. So sensitivity is the number. This is the formula we use, mathematical formula we use. You can see mathematical. This can be represented as this: number of true positive divided by number of true positive plus number of true false negative. You can go back to the table and see it. So this is it. When you add true positive plus false negative, that will be the denominator, and that will be plus C. So the denominator will be true positive on top here. So what you are going to have here will be sensitivity. So let's go to so when sensitivity, when a negative result in a test with high sensitivity is useful for ruling out disease. A high sensitivity test is reliable when its result is negative, since it rarely misdiagnoses those who have the disease. A test with 100% sensitivity will recognize all patients with the disease by testing positive. So a negative test result will definitely rule out presence of disease in the patient. So a test with high sensitivity has a low type 2 error rate. So the probability of accepting a false an hypothesis when it is not true will be very, very low. The probability there will be very low, and that's what we refer to as beta. So sensitivity, specificity is another one. It's related to test ability to exclude a condition correctly. You can see, consider the example of a medical test for diagnosing a disease. Specificity of the test is the proportion of any patient known not to have the disease who will test negative for it. So it's just the other side, the opposite of sensitivity. And this is the formula. And this, if a positive result will highlight a high probability of the presence of disease. So a test with high specificity has a low type 1 error. So this type 1 error rate will be very, very low. When it is very low, it means that test or the test you use here to carry out the screen, whatever this was test for a year, the precision is very high. When it is high, the type 1 error will be very, very low, which is expected of a good test. For example, the diagnosis test with sensitivity of 67% and specificity of 91% is applied to 2030. Now, this diagnosis test has been tested. So, and the sensitivity is 67%, specificity is 91%. It is already tested, and these values are confirmed in that particular situation. So I want to carry out this. So this is a particular example. This test, screen test at home. The test at home positive here. This row is positive. This is true positive. The positive predictive value can the formula TP over this. And this is from this patient with bowel cancer as confirmed on endoscopy. So this has been confirmed here, and these are the classification. Condition positive here, condition negative. It means these people have bowel cancer. These people here do not have. So this is sensitivity, this is specificity. The total here will be 2030. That's 2030 patients. So calculation, this is the calculation. If you go through the calculation, because this is very easy. Type 1 error here, that is an alpha. False positive rate is referred to as type 1 error, alpha. The false negative rate here is beta. If you see remember as statistical reference, how do you calculate power? That is 1 minus beta. That's 1 minus type 2 error, because the power of the test. Then we have the likelihood ratio positive, and likelihood ratio negative. The interpretation is here. What we want here is that we want to test what you are saying, whether it's correct or not. So with large number of positive, you can see the first positive is higher than false negative. You can see false positive here is 180. You can see the false positive is higher than true positive, and that is why. So if you have few false negative, so here we can see that it did, however, correctly, and it has 66.7% of all cases, and that is sensitivity according to the test as well. When you go to the example says 67% and specificity of 91%. So this is what we are testing here. So you can see, so MPV, that is negative predictive value, is giving us 99.5%. Now the initial screen correctly identify this, and those who do not have it, that is the cancer specificity. So for more on specificity and sensitivity, you can visit this site. Thank you very much.